So welcome to this class today. We are looking at relative atomic mass. What is relative atomic mass and how to calculate the relative atomic mass. Before you continue, make sure you subscribe and like. So what is a relative atomic mass? So first of all, you need to understand what is an atom. An atom, we know that it is the smallest particle of an element which can take part in a chemical reaction. Then we know mass. So when we say relative means there is a comparison in which we are doing in terms of mass. So an atom is the smallest particle of an element. So the only way we can measure its mass is when we compare it to a certain, when we do comparison. So usually you'll find that in some textbooks, when they say relative atomic mass, they compare the mass of an atom to the mass of one atom of hydrogen. But in other textbooks, they compare that mass of an atom compared to the mass of carbon, 1/12 the mass of carbon. So we have our relative atomic mass. So if you have an atom, here we have lithium, the superscript, this one is the mass number, then this one subscript, we have the atomic number. So you know the mass number is the number of electrons plus neutrons, and this one is atomic number is the number of electrons in an atom. So this one is the percentage abundance. Then another atom of lithium, here it has an atomic number of 3, mass number 7. Then we have percentage abundance 93%. So these two, they have the same atomic number but different mass number due to the difference in the number of neutrons. So we say these are called isotopes. So this type of where we have two atoms, the same element, having the same atomic number but different mass number, we call them isotopes. So how do we calculate the relative atomic mass? So you have the relative atomic mass. So we usually take the mass number and you multiply by the abundance, then divide by 100. So we have this atom, we have mass number 6, abundance 7%, divided by 100. We have plus the other atom 7, abundance 93, divide by 100. It will give you 42 over 100 plus 93 times 7 divided by 100. So have 93 times 7. 93 times 7 . 93 multiplied by 7, 651. So we shall get 693 divided by 100. This one will give us 69.3. Have 69, not 69, sorry. It will give us 6.93. So we shall realize that the relative atomic mass is usually near the atom with the most abundance, which is 93. If you look at here 6.93, it is near the mass number, which is 7, of the atom with the most abundance. So up to there, it is easy to calculate the relative atomic mass. Just take mass number, multiply by the abundance, divide by 100. Some question, they may want you to now get the abundance. Let's say you are given the relative atomic mass. You can still use the same example. Say you are not given the abundance and you are given the relative atomic mass as 6.93. Now they want you to find the abundance. If you are given such an equation, you have to say, let this one to be x, then this one to be 100 minus x, since you know that the abundance add up to 100%. So you still take 6 mass number times the abundance, which is x, plus again here mass number is 7 times abundance, which is 100 minus x, then divide by 100. It should give you 6.993. So this one will give you 6x plus 700 minus 7x over 100 is equals to 6.93. So you can multiply by 100 both sides. This one and this one will cancel, so you'll have 6x plus 700 minus 7x is equals to 683. Like the like terms, negative 7x the other side, it will be positive 7x, 6x the other side, negative, is equals to, you have 700, 693 to this side, it will be negative 693. So x is equals to 7%. So if this atom is 7% and we know that abundance add up to 100, so the other one will be 100 minus 7, get 93%, the abundance. So you can be given such like question, they want you to find the abundance, or they just find, and they want you to calculate the relative atomic mass.